Welcome to Bootcampverse, your universe of tech bootcamps. Good morning and welcome back to day 9 of the Code2Corporate Bootcamp. We're deep into week 2, where you're getting hands-on with the tools and platforms that power real-world tech projects. Yesterday, you took a deep dive into web basics, HTML, CSS, and JavaScript, and explored the world of the front end, the part of a website or app that users see and interact with. But here's a question. When you click a button on a website, where does the data come from? How does your browser fetch the latest updates, process your login, or show you a shopping cart? That's where today's topic, Backend APIs, comes in. APIs are the communication bridge between what the user sees and the powerful logic and data stored behind the scenes. Let's kick off by answering a simple but important question. What exactly is an API? API stands for Application Programming Interface. Think of it as a set of rules and protocols that allow different software applications to talk to each other. If you've ever ordered food at a restaurant, you already understand APIs, even if you don't realize it. Imagine the menu is an API. It tells you what dishes you can order and how to request them. You don't walk into the kitchen to cook your meal yourself. You tell the waiter what you want, and they bring it from the kitchen to your table. The menu doesn't reveal the chef's secret recipes or kitchen operations, but it tells you what's available and how to get it. In the same way, an API defines what data or actions are available, how to ask for them, and what kind of response you'll get without exposing the inner workings of the back end. Today we're focusing specifically on web APIs. These are the interfaces that let your web browser or even other apps communicate with back-end servers over the internet. Whether you're checking your bank balance, posting a tweet, or booking a cab, you're using APIs every single day, often without even realizing it. So, why are APIs such a big deal in the tech world? First, APIs enable communication between systems built with different technologies. Imagine your mobile app is built in JavaScript and your backend is written in Python. APIs allow them to work together seamlessly. Second, they promote modularity. This means you can build your front end and back end separately, update features independently, and even swap parts out without breaking the entire system. That's huge for teams working on big projects. Third, APIs are all about reusability. Your back-end service can power your website, your mobile app, or even public tools for other developers. For example, Google Maps provides an API so other apps can integrate maps and location features. No need to reinvent the wheel. APIs also fuel innovation. Think about how developers use Twitter's API to build analytics tools, or how shopping apps use payment APIs to process transactions. And finally, APIs make development more efficient. Instead of building the same functionality multiple times, you can build once and serve many. Now let's talk about the most common type of web API, the REST API. REST stands for Representational State Transfer. Don't worry about the jargon. Just remember that REST is an architectural style that lays out a few simple rules for designing networked applications. Most modern web APIs follow REST because it's straightforward and works well with the web. Here are the key REST concepts you need to know. First, resources. In REST, everything you want to interact with, like users, products, or orders, is a resource. Each resource is identified by a unique URL, like users or products 123. Second, HTTP methods. also called verbs. These are standard actions you can perform on resources. Get, to retrieve data. Think of it as reading the menu. Post, to create a new resource, like placing an order for a new dish. Put, to completely update an existing resource. Patch, to partially update an existing resource. Delete, to remove a resource. Third, REST is stateless. This means each request from your browser to the server must contain all the information needed to process it. The server doesn't remember your previous requests, making the system more scalable and robust. And finally, URL structure. REST APIs use clear, predictable URLs to identify resources. For example, users gets you a list of users, while users 101 gets you details for user 101. But how do APIs actually exchange data? That's where JSON comes in. JSON stands for JavaScript Object Notation. It's a lightweight, text-based format for exchanging data between a client and a server. JSON is incredibly easy for humans to read and write, and for machines to parse and generate. That's why it's the de facto standard for APIs. A JSON object looks like a set of key-value pairs inside curly braces. For example, id 1, name Alice, role developer, est. Here, ID, name, and role are keys, and each has a value. JSON can also represent arrays, ordered lists of values wrapped in square brackets. For example, ID 1, name Alice, ID 2, name Bob. Now, you'll see JSON everywhere in API requests and responses, so get comfortable with its structure. Now, how do you know if your API request worked or failed? That's where HTTP status codes come in. Whenever you make a request to a server, it responds with a 3-digit status code. Works informational. To success. For example, 200 OK means your request succeeded. 201 created means something new was created. Rex redirection telling you to look elsewhere. 46, client errors. 400, bad request, means your request had a problem. 401, unauthorized, means you need to log in. 403, forbidden, means you don't have permission. 404, not found, means the resource doesn't exist. 5, server errors. 500, internal server error, means something went wrong on the server's side. Understanding these codes is crucial for debugging your API calls and figuring out exactly what went wrong or right. But how do you actually interact with APIs as a developer or tester? That's where Postman comes into play. Postman is a fantastic tool for testing and documenting APIs. With Postman, you can create requests to any API endpoint. Choose your HTTP method, enter the URL, and hit send. For example, you can send a GET request to a public API like JSON placeholder and instantly see the 200 OK status code and the JSON response. You can also send POST requests with JSON bodies to create new resources, or make requests that intentionally trigger errors to see how the API responds, like trying to fetch a non-existent user to get a 404 not found. Developers and testers use Postman daily to understand how APIs work, verify functionality, and debug problems before integrating APIs into their apps. So, how do APIs fit into the real-world workflow at a company? Front-end developers rely on APIs built by back-end developers to fetch or update data. QA testers use tools like Postman to make sure APIs work as expected. In large organizations, APIs also allow different services like authentication, payments, and notifications to communicate in a microservices architecture. Think of APIs as contracts between teams. Each team can work independently as long as they stick to the agreed API. Let's recap what you've learned today. APIs are the bridge between applications. REST is the most common style for building web APIs. JSON is the standard format for exchanging data. HTTP status codes tell you the result of your request. And Postman is your go-to tool for exploring, testing, and understanding APIs. Tomorrow, we'll dive into database basics, where all that data the API provides actually lives and how it's managed. For now, your action item is to install Postman and try making some requests to a public test API. Don't forget to subscribe to Bootcamp Verse for more real-world learning that takes you from zero to job ready.